everyone in-house. I want to welcome you to Coding Kingdom Kids. We're going to go ahead and get started, but before we get started, let's say a quick little prayer and invite God into our learning process, okay? So here we go. Father God, in the name of Jesus, Lord, we want to thank you, Lord, for protecting us, Lord, and allowing us to get to this point. We ask that you would allow us, God, to receive everything that's being given to us, Lord, and that you would give us insight and the ability, Lord, to grasp the concepts that you are giving us, Lord, and to be able to be the great mathematicians, engineers, scientists that you have called us to be. In Jesus' name we pray, amen. All right, everyone, we're going to go ahead and get started. You can hit the next slide. Awesome. Great. So before we get started, for those online that may not know who I am, I wanted to introduce myself. My name is Sean, and I'm a current graduate student at VCU College of Engineering. I'm majoring in computer science. Aside from my studies at VCU Engineering, I'm also a media intern for VCU Athletics. You can see some of the photos I've taken. Cameras are kind of my thing. I love cameras. Outside of my education, some of my professional experience includes being an iOS and tvOS engineer for public broadcasting service. I also served as I served as a computer science educator for children for 3 years at CoVA. I've also interned as a back-end engineer utilizing SQL and Java for USERV. And some fun facts about me, which you can see in the top right corner of the slide, is I love Marvel and DC. I just started getting into collecting the comics, but I've been watching the movies for a while. I love superheroes. And one other thing is Formula One. I love Formula One. My team is Ferrari, even though we're doing terrible and the FIA is pretty much against us, but yeah, that's my team. Next slide, please. So we will go ahead and open up with our icebreaker. So young learners, when you came in, I asked you to grab a sheet, and I told you to color a piece of technology on the sheet that you use the most. So we're going to go around and share with each other the technology that we use the most. I'm going to start with Big Journey. What did you color? Okay, cool. And what's one fun fact you would want to share about yourself with everybody? It's okay if you can't think of anything. All right, Little Journey. Which piece of technology did you color? Okay. So it seems like you do a lot of tablet and gaming. That's awesome. Also, let's move over to Keej. Keej, what does you color? Okay. So you do a lot of entertainment. Awesome. All right, let's get to Jay. What does you color? Tablet. I love my Switch too, man. I got a Switch. Marlon, what does you color? Your t- okay, awesome. So it sounds like a lot of entertainment for you also. Entertainment seems to be where our crowd is. Carson, what does you color? Okay, awesome. So a little gamer. And Embry, I imagine Embry colored everything, right? Yeah, the phone. Embry likes the phone. Okay. And Lennox, I know you colored everything too, probably. You like all of the technology, right? Yeah. Okay, let's move on to the next slide. Sound is good. We're good online. All right. Next slide is today's learning objectives. So today's learning objectives include what is data structures, what are data structures, and algorithms, the role that data and data structures play in performing in our algorithms. Next slide, please. So the first thing we're going to talk about is what is data. Does anybody in here have an idea of what they think data is? I didn't put the answer up, so it kind of defeats the purpose. What do you guys think data is? Marlon? Okay, you said a keyword stored. That's good. Keej? Knowledge. Yeah, we can learn things from data. So you guys hit some of the key points. So data is a collection of information that represents ideas, objects, subsets of people. Subsets just means groups of, and we can use data to make conclusions, to make observations, to make predictions. We use it for, I know a lot of you guys like AI and what y'all call it, the AI brain rot. A lot of your brain rot is created from, from data. So these AI, these neural networks will take data and they'll learn from the data. They'll look at the things about it and they learn from the things that we've already fed it and generate some new things, which is awesome. So I want you to remember that data is just a collection of information and that information tells us things about whatever we want to learn about. People, populations, trends, anything. Next slide, please. So data can either be qualitative or quantitative. So qualitative, when I say data is qualitative data is the things that you can observe with your 5 senses. So if you can see it, taste it, smell it, touch it, or hear it, those things are describing qualitative facts about our data. Quantitative data is data that is measurable. So anything that you can count, that you can graph, that you can plot, that is quantitative. It's finite, you can make it numerical and learn statistics and facts about it. Next slide, please. Data also has forms. And we're not gonna look at all of the forms of data because it's a whole lot of forms of data. But the 3 that I want us to focus on are int, Boolean, and string. So int is short for integer, and an integer is just a regular number, a regular whole number, like 4, 5, 23, 1,000, 1,000,000. Boolean is true or false. So if I give you Boolean data, I'm just asking you, hey, does this hold a true value or a false value? And then string is just words, regular old words. And you can see I put a crossword up there to show you. And it doesn't have to be words that make sense. I can drag my finger across the keyboard and put a bunch of random letters, and it's still a string because it's consisted of letters. All right, next slide, please. So I want to see if we can identify some different data types up here. So remember, we introduced the Boolean, which is true or false. We've got int, which is short for integer. That's just a whole number. And then we had strings. Does anyone see an integer up there? Keech? Yeah. Anybody else see any other integers? Jay, I saw you had your hand up. That's a Boolean. That's a Boolean. But we're going to get the Boolean soon. Marlon, did you have one? 633. Awesome. So you guys got the numbers. Jasiah pointed out the Booleans for us, true and false. Can anyone give me an example of a string that they see up there? Journey? What was it again? Yes, the books. It almost looks like a book page. That's a street sign. Yes, but that does have a string on it. Awesome. And some of the words that we see up there. So you guys are getting it. The one that's not kind of obvious, I don't think anyone would have gotten it without me saying it. The shoe, I was hoping you could think of a shoe size, and that would be an integer, because you wear a size 5 or size 6. That would be an example of an integer. All right, next slide, please. So we're going to go ahead and get our first exercise, because I don't want to sit here and talk with you guys all day, because I wouldn't want to sit through that. So we're going to go ahead and fill out this worksheet. Well, it's not a worksheet. It's something fun to do. So I'm going to hand you this page right here, and it's reminiscent of a Facebook page. How many of y'all's parents has a Facebook? I know a lot of y'all parents has a Facebook. So on this, I want you to fill out some data about yourself. So stuff such as your name, your school, your favorite color, your favorite food, favorite song. And I just want you to write it down all on this page. And after you've done that, I want you to circle a piece of data on here that you think is quantitative. Remember, quantitative data is numerical data. And then I want you to put a square around something that is a string. Remember, a string is just letters or a word, okay? So we're gonna go ahead and pass this out. And I'm gonna let y'all go to the back table again and get this done, because writing in your seats would be kind of tough. So let's go to the back table, everyone. Let's go ahead and get this started. We're gonna go ahead and set a timer for about 5 minutes. Online audience, we're gonna be right back with you, okay? We'll be back in 5 minutes. All right. So we are back, everyone. Seems like everybody had fun coloring their page and talking about themselves on their little Facebook page. So let's go ahead and share some of the things that we discovered about each other. So who wants to share a piece of quantitative data that they had on their sheet? Josiah, what you want to share? Okay, May 23rd. 23rd is numerical. That's good. Marlon? Pokemon books. Okay, that's a string type. I told y'all the square a string type. That's cool. Dinosaur books. Josiah, you want to add some more? Spaghetti. I like spaghetti. I just had spaghetti yesterday. Anybody else want to share something? All good, all good. Seems like we had a bunch of fun, and that's all that I care about. And we're learning together, so cool. Let's go ahead and move to the next slide, please. So data, a lot of times when we encounter data in its raw state, in its natural form, it's going to be very unstructured. It's going to be chaotic. It's going to be messy. So think about a company such as Facebook, and they're trying to collect all this data about posts and usage and the amount of hours that people have been online. So when they look at all these posts, it's going to be a mixture of images and audio files and videos, links, lots of strings, because comments that people write online will be strings. Those are words. And they're going to have to find ways to organize the data so that they can work with it a little better. That leads us to data structures. Next slide, please. So data structures, if we look at the definition on our slide, is a way of organizing and storing data in a computer so that it can be processed efficiently. Data structures promote order and help us in problem solving. So data structures is a way of us taking the lots of unstructured data, those numbers, those strings, lots of other things that we talked about, and storing it in a compact and organized way. So that way your computer can access it faster and more efficiently. You're not wasting resources. It's almost like when your mom tells you to go clean up your room. When your room's a little dirty, when you got clothes all over the place, your bed is unmade, you got your games on your desk, it's hard to find what you're looking for, right? It's going to take you a little bit longer than if everything was organized and clean, you could just go to the spot that it's supposed to be at and pull it out real fast. Same thing with the computer. All right, let's go to the next slide, please. So there are so many data structures we could talk about. We could sit here all day and talk about data structures. But I want to give you three main data structures, and then we're going to focus on only one of them, okay? So the first data structure we're going to talk about is a one-dimensional array. Can someone say array? Good, cool. Array. So an array, you can think of it as like a hallway of doors. Imagine you walk in a hallway, and there's a lot of doors. And every single one of those doors has a number on it. So you go to a door, maybe you have 5 doors, and the first door has 1 on it. The second door has 2. Third door has 3, and so on. When you open up the door at a specific number, so maybe I open up door 3, there's a room behind that door, but I don't know what the room looks like. You won't know until you open it up and step in. It could be a kitchen, it could be a bedroom, it could be a dance room, it could be the door to GRC. You never even know. But it's the same way with an array. An array is a structured list of elements, and every single one of those elements has a number, and that number is known as an index. You can think of that as like the address. I don't want to say an address. You can think of that almost of like an ID. If someone told you to pull out an ID in your pocket and identify who you were, you could think of that element, that index, as an ID. And when you take that specific ID, you get a specific element, and that element is holding a value. That sounds like a lot, but we're going to go through a picture to make more sense of it, okay? The next data structure I wanted to talk about was a stack. Does anybody know well, from hearing the name of it, could you infer what a stack would be about? Keach? Things on top of each other, exactly. So you have a data structure in computers called a stack. That was really good, Keej. So stack is where you have, let's say we take methods. A method is basically a function or a way of solving something. It'll be a predetermined set of instructions that you call, and when you call that method, it'll do some things that you told it to do. So if we have a stack, we can stack a bunch of calls to methods on each other, and the last thing that you stick on top will be the first thing that you can pull out. It's just like if I were to take this folder, my iPad, and take my phone and stack them all on each other. What would be the thing that I would be able to take off the stack first? Would you, Keach? The phone? What would I be able to take off next, Journey? The iPad? So you see, it's kind of like stacking in real life. Stacks in computers stack function calls on top of each other, or stack pieces of data on top of each other. And the last thing in will be the first thing to go out. So whatever's on top will be the first thing to be pulled out. And you can remove that topmost element or that last thing on top by calling a method called pop. So you pop it off of the stack. The last data structure we're going to talk about is a queue. So think of a queue as going to McDonald's, and you have a drive-through, and there's a bunch of cars. And the thing about drive-thrus that are not that fun is if you get there late, you're going to be all the way in the back of the line. The first person to be there will be the first person to be served. And that's how a queue works. We can put data in a line. We can put them all behind each other sequentially. And the first thing that got there first will be the first thing that we pull out. So it's first in, first out, kind of like a drive-thru. Whoever pulls out first is going to be the first one to get their burger. All right, next slide, please. So I gave you 3 data structures, and I told you I only really wanted you to remember one. So this one data structure that we're going to talk about is an array. So if you look up at the screen, you see a visual representation of an array. So remember, it's going to be a list of elements, or it's going to be a list of things. And each one of those elements holds a value. And every single one of those elements has something called an index. So if you look at the picture, if I say I want to see what the element at index 2 is holding, I'll look at the index number. You see the number 2. Element number 2 is holding a black car. Can someone tell me what element number 4 is holding? Marla? Blue car, good, good. If I told you to tell me what's at index value 0, what value is that element holding? Keach? Almost. One behind it. Carson? Orange. Good, Carson. Good, good. So remember, you take the index value, and that index value will be the element that you access. So if I say I want to go to index value 3, the element at index value 3 is holding a pink car. You use the unique index number to access the value held by that element. All right, next slide, please. So we can use data and data structures that we just discussed, such as stacks, queues, arrays, so many other ones that I couldn't talk about because there's so many of them. And we can utilize them in algorithms. And algorithms are a finite set of instructions. Finite means a limited or numerical. It's not limitless. It's not foggy, it's not confusing, it's set in stone, it's defined, it's finite, it is there, it's defined. An algorithm is a finite set of instructions that will allow us to correctly solve a problem or perform a computation. So if we come up with an algorithm or a set of instructions to perform some task and it doesn't correctly solve it, that's not a very good algorithm. We want to come up with algorithms that will correctly solve a problem. So you'll give it some input, such as some numbers, some data, and the set of instructions will use those data, will use the data that you've given it to give you a correct output. Next slide, please. So yeah, this is an example to make it a little bit easier and visual for you. This is our pizza recipe algorithm. Does anybody in here, if you had to think about it yourself, what would be the recipe for pizza? Jasiah? Get the dough. Okay. What would be the next step? Marlon? Pizza sauce. Okay. What would be the next one? Keach? Cheese. What would be next after cheese? Jasiah? Pepperoni. And then once you got all the ingredients, what do you got to do with it? Marlon. Eat it. No, not eat it up. It's not cooked yet. Oh, heat it up. Okay, good, good, good. And then once you cooked it and you take it out of the oven, what are you going to do with it? Carson, I saw your hand before. What was it? What did you say? You don't know? Little journey. What are you going to do to the pizza before you eat it? You take it out the oven. What are you going to do? Almost. We could put it in the box. Almost. But if we want everybody to get a slice, what do we got to do? Big journey? Cut it. Awesome. So y'all just came up with the pizza making algorithm, okay? So your inputs were dough, cheese, pepperoni, and tomato sauce. And you came up with the finite or numbered set of steps that would be required to make or output a pizza. There's one more input I wanted to give you. If you look there, we're going to talk about variables in a second. You'll see something that says int x equals 6. Remember, int is short for integer, and integer is a number. So we're going to have a data type variable called x. Its name is x, and it's going to hold an integer value. And the integer value here that was specified was 6. So x equals 6. And if you look at the top of the algorithm in the middle, it says repeat x times to fulfill x orders. That's kind of what a computer does. When you give it data, you can specify how many times it should loop. It's something called a for loop, and we'll talk about that later. But we specified in our input, we want this set of instructions to loop 6 times. And x doesn't have to be 6. It can be any number. It could be 10. It could be 0. It could be 1,000. It could be 1,000,000, and the computer would do it for you. Computers are not that smart because they really don't know what to do. You have to tell it what to do. You make it smart, okay? Next slide, please. So we accomplish all of this programming that we were talking about using something called a programming language. And a programming language is just a human understandable language used to express instructions to a computer. We talk by speaking in English. We use English words. So we'll use programming languages like we see up top, such as Swift, Python, Java, C, and lots of other ones I didn't get to list off. And we'll use our human understandable language to convey to the computer what we want it to do. The computer doesn't talk in English like us. Its CPU, or central processing unit, uses something called bits. And it'll use a sequence of bits. And bits are zeros or one. And those zeros and ones tells the computer basically what to do. So you give it this programming language, the computer will turn it into bits, and it will start carrying out all those instructions that it gave you in a way that it understands how to do it. Next slide, please. So remember in our pizza algorithm, we had int x equals 6. That was a variable. And a variable is nothing but a named alias. An alias is like an identity or persona. A named alias that stores a value that can be accessed or modified. So we have some examples up here. And if you notice, we're using the 3 data types that we talked about today. Integer, which is a whole number. String, which is just an alphabetical letter or a word. And int, I think I said int already. Boolean, which is true or false. I'm sorry. So if you look at the examples up there, you start off when you're making a variable by saying, what type of data is this? Is it integer? Is it Boolean? Is it string? And you're going to specify the type. Then you name your variable. You can name the variable whatever you want it to be. I could name my variable Keej. I could name my variable Carson. I could name my variable Jasiah, Marlon, Journey, Celeste, Keith. I could name it whatever I wanted. I could name it Batman. I could name it race car. I can literally just name it X, Y, Z. It doesn't matter. So you specify the data type, you specify the name, and then you specify the value that you want to be stored there. So if you look at the example, we have Boolean, which is the type, smart, which is the name of the variable we decided to make, equals true, and it holds a value of true. Same thing with this string. So we specify the type, which is string. We specify what we want to name the variable, which is name, and it equals a value that we specify. And for this one, I chose my name, Sean. String name equals Sean. You can see the same thing with the int age equals 22. Next slide, please. So today, if you find an interest in coding, you'll be able to learn how to do something like this. You can take the data that we learned about, the data structures to organize that data, and variables to hold those numerical values or alphabetical values or whatever. And you can use all of those tools to make an algorithm that will make a program to perform a certain task for you. So if you look at the screen, this is a project I worked on by myself maybe about a year ago, I think. I used a programming language. Remember, a programming language is just a human understandable language to communicate to a computer. I used a programming language called Swift. And Swift is the programming language that makes this work. This is the iPhone. Swift is used specifically for iPhone. You couldn't use it for for Android. Swift makes our MacBooks run, our iPhones, our iPads, our Apple TVs run. And if you look at some of the code, you can see some of the things that we talked about. So maybe you see this thing that says let Pokemon API equal Pokemon API with some brackets. So I created a variable called Pokemon API, and it's storing a value there. This value is a little different. I'm not going to get into it because I don't want to confuse some of the things that we learned about already. If you look at the second image, you can see that we have an if statement, which we'll talk about later. An if statement is just a block of code that asks the computer a question. So if you look at this section right here, there's a lot of if ones. I'm trying to figure out one that you could look at. This one is the simplest. If data equals nil. You might not, it's right in the middle of the second picture. If data equals nil. We're asking the computer, hey, is my data empty? And if so, we're going to print out a statement that says no image data received for, and then we'll specify the species name. Also, you can see the overall general overview of the code that we have here. So the first one, like I said, we had that Pokemon API. An API is basically an application programming interface. It's something that stores a bunch of functions and sometimes data in itself, and we can call it and access the data. That if statement I was talking about, we're ensuring if we successfully receive data that actually has values. And then once we actually have the data, we can start making things with it like we specified earlier. So I took this data, which was some images of Pokemon, their name, their types, and I stored it in a data structure that was custom made by me. It was a UI view. I can't talk about UI views today, but if we kept going, I could explain the concept to you. But just know it's a data structure, and it's a way of organizing those Pokemon in those grids right there. Next slide, please. So I did enough talking at y'all. I told y'all I don't want to talk at you the whole time because I wouldn't want to be talked at the whole time, okay? So we're going to, do y'all play Kahoot? Cool. So we're going to do a Kahoot and review everything we just learned, and then we're actually going to code a game together in Scratch on our tablets and our computers, okay? So we're going to go ahead and pull out our iPads, and if you know how to do it, go ahead and get onto Kahoot. And if you have a friend besides you that doesn't know how to do it, go ahead and give them a little bit of help. Online audience, I will be right back. I'm going to go get the access code for the Kahoot so I can share it with you all if you want to review with us. I'll be right back. All right, I don't know who is wiggly wobbly, but y'all are deep frying me. Y'all are deep frying me. You are wiggly wobbly? Okay, online audience, if you want to join our Kahoot, the code is 9925321. I'll say it again. Online audience, if you would like to join our Kahoot, our join code is 9925321. 9925321. I'm going to give the kids a second to join, and then we'll get started with it. Yes. Yeah, you can play on my sister's phone instead. Monty, get rid of the first side. Keep the side with a bunch of H's. Oh, got it. Thank you. I don't know who said they're Spider-Man, but I'm Spider-Man. All right. 2, 3, 4, 5, 6. We're missing one person. 1, 2, 3, 4, 5. Oh, no, we're not. I counted Embry. She can play on my phone instead, so she don't, 'cause I don't know who to All right, I think everybody's on. Okay, everybody's in that wants to play. Thumbs up if you're good. All right, it looks like a lot of thumbs to me. Monty, you can go ahead and start the Kahoot. Can I see the questions from this far back? Lord. All right, first question, guys. So question number 1, what is data? What is data? I cannot read those answer choices. Y'all can gather up to the front if it's a little, I didn't notice. So the red one says a collection of information that represents objects, events, or ideas. Okay, it's about to run out of time. All right, but data is a collection of information that represents objects, events, or ideas, okay? Next question, Monty. Yeah, it was two, just you. All right, Journey is in the lead, big Journey. What can data look like? What can data look like? Red is words and numbers. Blue is symbols and observations. Yellow is unorganized multimedia, such as images, blah, blah, blah. Or all of the above. All of the above. All of the above. Awesome, guys. Next question, y'all. So who's in the lead? Little Journey, okay. All right, next question. Unstructured data does not have a predefined format or structure. Is this true or false? Unstructured data does not have predefined format or structure. That means that is it organized or is it not organized? True. Unstructured data does not have organization of any kind. It's all right, Lil Jordan. You were in the lead. You might still be in the lead. Let's check the leaderboard. Oh, Carson. Okay. Marlon's in second, Lil Journey in third. What possible values can Boolean data types store? Can it be whole numbers, words, decimals, or true and false? What can a Boolean data type store? True or false? Good job, guys. Boolean data types is true or false. All right, Carson is still on top, y'all. All right, next question. Quantitative data is information that cannot be measured, counted, or expressed with numbers. Is this true or false? Quantitative data is information that cannot be measured, counted, or expressed with numbers. True or false? That is false. Good job. Most of y'all got that right. Good job, Carson. All right, let's see the leaderboard. Y'all, Carson is holding number one down. All right, let's keep going. Question 6. A valid algorithm must be a finite set of instructions. What does finite mean? We talked about it briefly. You think you got it? A lot of y'all got that right. Good job. You got it right, Marlon? Carson got the fire emblem beside him. He is killing it. Oh, man. What data type does the following variable store? So, look, this data type says string superhero equals Batman. What type of data type is that? It's right in the name. The type is red. It's okay. A lot of y'all got that right, though. Good job. Good job. All right, next question. Let's see the leaderboard. Carson's still on top. Spider-Man is climbing. Journey is climbing. What value does the following variable hold? What value does this variable have? So a string, superhero equals. What does it equal? That's the value. It's too easy? Awesome. Y'all got that right. That was good. Batman. Carson's still on top. Next question. Oh, you gotta go. I'm sorry. How do we access values held by an element in an array? How do you access the value of an element in an array? Do you use the element value? Do you use the array value, a random number, or the index value? Yeah, what do we use to pick out the cars? Ooh, who got that right? One person got it right. Who got it right? Spider-Man. Spider-Man is too old. Peter Parker should not have gotten that. Spider-Man is on top. Next question, this is the last question. What method do we use to remove an element from the top of a stack? Do y'all remember? Is it pop, remove, push, or remove from stack? You think you got it? Yeah, if you look at the picture, the answer is up there. Two of y'all got it right. Cool, cool. So if you want to remove something from the stack, you pop it from the stack. That's the method you call. So let's look at the final leaderboard. Who won? Podium, third place goes to Big Journey. Good job, Big Journey. Second place goes to Spider-Man. Come on, Spider-Man. And first place is Carson. Good job, y'all. Carson got first place. Awesome. So y'all clearly learned something, and that's what I wanted. So good job to all of you. Good job. All right, guys, so now we're actually going to code something together. So I'm going to go to the back, and I'm going to hook up my computer so that y'all can see and learn with me, okay? Online audience, I could not manage both in-person and online learning at the same time, so I pre-recorded a lesson for you to code with me. So there's a pre-recorded coding lesson that's about to start on the stream now. You can learn at home how to code. Hello everyone. Once again, I wanted to make sure that the online audience was being included in this activity because I was not sure how to make sure I could physically meet the class that I was working with and also the online audience. So let's go ahead and get into it. So either on your laptop or your tablet, you can navigate to scratch.mit.edu and you'll be brought to a screen that looks like this. So Scratch is a simplified version of a programming language. We're not going to actually be doing actual typing with code because that's a little much for our young learners, something that can be grasped with little prior knowledge. So let's go ahead to the top portion of the screen and click Create. And today we're going to be creating a apple muncher game. So we're going to take a sprite. They start you off with a cat sprite, which you can change to anything that you want it to be. You can do this by trashing this one. Yes. Hitting a little cat down here, choose a sprite, and you can pretty much choose whoever you want to be. So we're going to take a sprite and we're going to take an apple and we're going to have that apple fall from the top of the screen. And every time our sprite touches the apple, we're going to gain a point and have the apple go return to the top of the screen at a random x-axis value. And if you're unsure of what an x-axis value is, it would be any value or position along this horizontal line right here. So to get started, let's move our sprite down to the bottom of the screen and let's choose a background. We're going to navigate to this lower portion of the screen here and click choose a backdrop. Personally, I like what do I like? Me personally, I like the way this jungle looks. So we're going to be in the jungle when we're eating apples, okay? So let's go ahead and we have our sprite. Let's also add our apple. So we'll go down to choose a sprite again and we'll navigate to food. I don't want to restrict what you want your game to look like. So it doesn't have to be an apple because the core operation of the game will be the same regardless of the sprite that you choose. So choose anything. I guess I'll change it to a taco. We'll eat a taco. This taco is huge. So if you want to shrink your food, much like I do, you could come down to size and you could type in a random value that's smaller than 100, maybe 50. Yeah, maybe 30. That's better. So let's get started with our actual coding. This is the exciting part where we're going to put what we learned about data and data structures and algorithms to use and variables. We're going to make sure we create a variable to keep track of our points. But let's not get ahead of ourselves. We're going to take it one step at a time together. Let's navigate to the events section and we're going to drag this green flag on to our canvas. After we've done that, we will go ahead and scroll down to the variables section right here where you see my clicker. And we're going to click make a variable. And we're going to name this variable score. So now we have a variable called score, and this score variable will be of data type integer or int, like we reviewed earlier. And this int data type variable will hold our score. So first we will begin by setting the score to 0. So you drag the set, and it might say my variable or something else. It's most likely going to say my variable. Drag it and click it with your flag, and we're going to change it to score. So now if you look back at your sprite area, you have a little variable in the top left corner of your game that's named score. So now let's navigate to the control section. We'll click control here and you'll see this little block that says forever. Drag the forever block under your set score to 0. This forever block is a loop. Basically a loop will take the instructions as you place in the middle of it or the body of it, and it will run it until you tell it to stop if you're using a for loop. because you specify the amount of times it will run. Here, this is a forever loop, so whatever instructions we give it, it will run forever. So what are we setting ourselves up to do here? We're setting ourselves up so that forever, the entire time that this program is running, we're gonna have our food sprite right here, this taco or whatever you chose. We're gonna have this food sprite constantly check its location on the axis, this invisible axis. There's a y-axis here. And y-axis is just the vertical plane on your screen of your game. You're going to constantly have that food sprite check its position on this y-axis. And when our y position gets to a certain value, we're going to have it pop right back up to the top. So once this food sprite goes all the way down the y-axis, we'll say to the foot of our sprite right here, that is at y position -148. So once our y position is less than -148, we're gonna have our food sprite pop right back up to the top by setting it to, let's see what the y value would be up here, 163. And you're wondering how I got this value. If you look under your game, there's a little area beside this y. You see the vertical arrow that I was talking about. It's talking about that vertical plane here. And when you set your food all the way at the top like this, on that vertical plane, it's at y equals 180. And again, we're gonna have it check until it drops to the bottom, which is roughly -153 right here. That's when we'll have it pop right back up to the top. So follow me. Let's go to the left section of our screen and we will click motion. We're gonna set our initial y value. So we're gonna click this set y2 block and drag it inside our forever loop. And we're gonna change this value from -153 to 182. And what that does is it starts our taco all the way at the top of our screen. And since this is going to be a game where we're going to have the food falling and we're trying to catch it, we're going to want to not have it start from the same position every single time. How boring would it be if it reached the bottom and boom, it came to the same exact position right here at the top of the middle of our screen. Did it again, boom, it comes to the top middle. It would be very redundant, it would be boring, it would be predictable. Nobody would want to play the game. So we're going to have our sprite be able to generate a random x-axis value or horizontal position to fall from. So once it respawns at the top of the screen, we're going to have it generate a random x-axis or horizontal position to drop from. And if that sounds confusing, it's okay. We're going to do it together. So let's go back to the motion section. We're already here. And we're going to click the block that says set x2. And yours is probably going to have a different number here. It's just depending on where your food is sitting on your screen. So set x2, we'll place that right under the set y2. And again, when we have our food sprite drop to the bottom of the screen and it navigates right back up to the top, we don't want it to generate at the same position. So we're gonna set x to a random value that can either be at this end of the screen or that end of the screen. And you might be saying, well, how do I know what values to set it to? So here's a little trick you can do. You can pick up your piece of food and move it all the way to the left right here. Now let's go all the way back down to where we had this x and y value. If you look at the x plane, this is -236. In the worst case, if our taco spawns all the way on the left edge of our screen, the farthest over it could be is x position -236. And if you're thinking, how can we get to the right side of our screen? Well, if the farthest to the left is -236, the farthest to the right we can go is +236. It's just the inverse of the value that we have. So let's set our x value to a random value between -236, which is all the way to the left side of our screen in the worst case, to 236, which is all the way on the right side of our screen in the worst case scenario. So to find this, we will go to the green section right here named operators. And we'll pick this block that says pick random. And we're gonna drag it inside of our set x2. We're gonna set this x value, like we said, to -236 and +236. So now that we have that in place, we will actually insert the code that continuously check where our food sprite is on this y-axis, not x-axis, y-axis. It will continually check the whole time. It's going to ask your taco or whatever you have here, are you at the bottom yet? Are you at the bottom yet? Are you at the bottom yet? That's annoying, but that's what the computer is going to be doing. It's going to keep asking that. And once it hits the bottom, it's going to say, oh, you're at the bottom now. So let's go ahead and pop right back up to the top. Okay, my friend? So again, let's go to the control blocks. And once we're in the control block, we will click this block right here that says repeat until. So what are we repeating? We're repeating the act of changing our y-axis value. We're going to continuously subtract from our initial y value so that it simulates dropping all the way down to the floor. That may sound a little difficult or hard to understand. So let me put it a little simpler. It's going to take the number that we have, this y position. We're going to start at y equals 182 according to our code. And in order to have our food drop to the bottom of the screen, we've got to make this y value smaller. So how are we going to do that? How do you make a number smaller in general when you think of math? You just subtract. So if we keep subtracting continuously, it will simulate our food dropping down to the floor. Hopefully I'm not sounding a little redundant here. I'm just trying to make sure that we're all getting it, okay? So let's go to the operator section again. And we're going to choose this less than sign here. So until, let's go to our motion block right here. And we're going to scroll down a little bit and you'll see a block that says Y position. Drag that into the blank section here. And the bottom of our screen that we wanted to agree on, I believe, was -157. Yeah, somewhere around there. So right here, we will write minus, that's -157. Young learners, if you see a minus sign or a negative sign in front of your number, that just means that your number is a negative number. You may or may not have learned that in school yet. Until we hit the position -157, we're just going to keep subtracting from this y value. So we're going to change y by. You see this block right here that says change y by. Drag it inside of there. And you're going to put a subtraction sign, a negative sign, whatever you want to call it. Whatever makes it easier for you to understand. So let's look at what our code can do so far. So we're going to go ahead here and click this green flag. And look, it's raining tacos or donuts or cakes or whatever you chose to make your food game rain. So that's awesome. We have made it so that our code can spawn our food at the top of the screen and continuously subtract from its Y position value so that we can make it drop to the floor. And once it's hit the floor, we will have the food spawn back at the top at a random position at the top of our screen. And you can actually see here the Y value where we're subtracting -10 or -10 continuously until we hit the floor. So now we want to go ahead and write the code that will actually allow our player to score. I could teach you all how to move the character with the WASD or the arrow buttons, but I don't want to get too complicated here. We're going to score by moving our sprite manually, okay? We're just going to click on it and drag it. So let's make sure that we've clicked on our taco sprite here. And we're going to create the code, and it might not be a taco for you. I'm sorry if I'm confusing you. Whatever piece of food that you chose. And we're going to create the code that will actually allow us to score. So let's go right back to the events right here and click this green flag. Then let's go back to the control section and we'll have another forever block, which again is just a loop. It will run our instructions inside of that forever block forever. It won't stop. It will keep going. Inside of that forever block, we're going to have this if block. You see this right here? It says if with this hexagon and then. Drag it in the body. So now let's go over to the sensing block. This right here, sensing. And then we're going to choose this first block here that says touching. And we're going to drag it into our if. So this if block right here is basically asking us a question. It's saying, hey, are you touching the mouse pointer? But we don't want to be asking that. We want to be asking, are you touching Gobo, or are you touching my sprite? Whatever the name of your sprite is, go ahead and click that. Mine is named Gobo. So this loop will continuously ask, hey, are you touching Gobo, Mr. Taco? It's asking the taco. And if so, we're going to have the taco go all the way back up to the top at a random position horizontally and drop down again. But also we're going to have a little sound play to act as if we've ate the taco and a new taco is coming down. We're also going to increase our score by 1. Sounds like a lot, but we can do it. We're going to do it together, guys, okay? So navigate to the motion section. We're going to click the set Y2 block right here. Drag it inside of your if. We're going to move it right back up to the top of the screen. And remember, the top of our screen was y equals 182 if you look at this other piece of code that we wrote. So let's change this to 182. And then we're going to do the same thing. Once you move it to the top, you want it to also be at a random position along this horizontal position. Because if our food sprite were to generate at the same position, like I said earlier, the game would be boring. Let's go get the set x2 block that we used earlier and drag it in the if section. And we're going to do the same thing. We're going to pick a random position. So let's go to the operators section and we're going to choose this pick random. And we're going to drag it in here. -236. And we're just copying what we have here. -236 to +236. So if you touch Mr. Gobo, I'm going to send you right back up to the top. That's what this code says. Also, when we do that, we're going to go to this sound section here. And we're going to choose the first one. Play sound pop until done. So now every time we eat the food, not only is it going to go right back up to the top, but we're also going to have a pop noise play or pop sound play. And then we're going to go back to the variable section right here. And we're going to choose the change my variable by block, this second one right here. And we're going to put it right under the play sound. And instead of my variable, we're going to change it to score. So that way we're actually changing that integer value being stored by our variable named score. And we're changing it by 1. So this whole block is saying, hey, Mr. Taco, if you touch Gobo or whatever sprite that you have here, you're going to pop right back up to the top at a random position and you're going to give me a score. You're going to add to my score. You're going to increase my score. Now, if you press the green flag, look at that. Let me turn my sound up. Look at that. We have a game. Okay, I was getting distracted playing the game. I was talking and got distracted because I actually was trying to eat the taco with my sprite. But look at what we've done together, guys. We've created a game where we have a food sprite that spawns at the top of the screen. And that top of the screen is holding a Y value. In our case, we see it's 182. And we continuously subtract from that position to simulate our food dropping. If it's hit the floor without touching our sprite, it pops right back up to the top. In another case though, if you look at this second block of code we wrote right here, if this food is falling and it touches our sprite, it's going to play a pop sound. It's going to change the score by 1, or it's going to add to our score. And remember, score is an integer variable we've created that's holding some data, and that data is our score. That is what we're observing during the runtime of this algorithm. But if it touches our sprite, we increase our score, play a pop sound, and send it right back up to the top. And just like that, we have our little game, guys. So there we have it, guys. We've created our first ever game together in Scratch. And I don't want you to stop here. So I want you to continue building on what we've learned today on data structures, and algorithms. And I want you to grab a guardian or a parent, have them sit with you, and watch some Scratch videos. Look up some tutorials, figure out how to code a little bit more, and see what you can come up with. The sky's the limit. Whatever you want to learn, you are able to do. I want to thank you all for joining me today for Coding Kingdom Kids. I truly enjoyed being able to learn with you today, and I look forward to hopefully seeing you again in the future. All right, see you all later. Thank you. Bye.